Welcome to our video. Today we're going to discuss a fascinating problem related to runtime detection of the operating mode for x86 code. The problem lies in identifying whether the code is running in a 16-bit or 32-bit mode at runtime, without modifying any crucial registers, flags, or using the stack. Let's dive into the solution provided a clever approach that involves making temporary changes to the register ESI. By manipulating the ESI register with specific offsets in both 16-bit and 32-bit modes, we can accurately detect the operating mode without interfering with other essential components. In 16-bit mode, the code uses LEA to adjust the SI register and then proceeds to the appropriate code path based on the result. Continuing with the solution, in a 16-bit mode sequence, after adjusting the SI register, the code executes the necessary instructions to determine the mode and perform the desired operations. The use of LEA with different offsets enables the code to differentiate between 16-bit and 32-bit modes effectively, providing a reliable runtime detection mechanism. Moving forward to the 32-bit mode segment of the solution, the code adjusts the ESI register with a distinct offset to discern the operating mode accurately. By utilizing specific memory operands and instructions, the code can determine the mode dynamically without relying on conventional methods that may not be suitable for all scenarios. To wrap things up, we have explored a creative solution to the challenging problem of detecting the operating mode for x86 code at runtime. By leveraging clever register manipulations and strategic instruction sequences, the code can effectively identify the mode without causing any interference or modifications to critical components. We hope you found this discussion informative and intriguing. Remember to like, subscribe, and leave a comment below. Thanks for watching.